Hello everyone. Today let's solve the problem number 1405, longest happy string. Right, so what the question states here. So we are given count of letters A, B and C. See here in the input they have given this one A, B and C. Right, so we are given count of letters A, B and C. What we must do, we must build the longest possible string containing only these letters. Right, so we must build the longest possible string containing only these letters, such that there are three criteria or the three conditions here. No three identical letters appear consecutively. See here, only two letters can appear consecutively, right? So no three letters can appear consecutively. So you don't see any three letters appearing consecutively in the output part. You can clearly see here, right? So it can be of any order. See, they have given double C, B, double C, this one A, double C as well, right? So it doesn't matter order, but no consecutive this one. No three identical letters appear consecutively. Just keep this in mind. The second criteria or the condition is here: no letter count exceeds the given limit. No this one letter count exceeds the given limit. So what's the limit here? Just give me a second here. Yeah, no letter count exceeds the given limit. See, A we have been given only once, and A is present only once here in the output, and B we have been given once. B is also present only once here, and C we have been given 7. We have made use of the C 6 times here. Double C, double C, double C. You can clearly see it shouldn't exceed the given limit, right? So if the multiple answers exist, then we can return any. See here, either we can return this or we can return this one. If the multiple answers exist, we can return any, right? So for the second one as well, see here, we have A 7, B equals 1, C equals 0, right? So A, we have double A, B double A, right? So it is the only correct answer in this case. So because we cannot have the triple A's, right? Three consecutive A's. So here we'll be considering double A, B double A. So the output will be this one, right? So they have given us wonderful examples just for the sake of understanding, right? So now, as we are completely familiar with the question, let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code. Just give me a second here. 1 second, man. So yeah, let's consider the same first example for the approach. First, let's discuss the approach, and then let's write the code, right? Approach followed by the complexities and then code. So now I have considered the same first example for the this one approach. So what we will do, we will put so we will go with put of count and char. First of all, we will be making use of, just give me a second here. Yeah, first of all, we will be making use of the priority queue. First of all, we will be making use of the priority queue or heap. Either you can go with the custom heap or the priority queue, right? So I'll be making use of the priority queue in this case. So we'll be making use of the approach priority queue here, right? So priority queue or the heap. So we will put count comma char of each letter into the max heap. So we'll be going with the max priority queue, right? So I'll be going with the max heap here, right? So we will be putting put of count comma char, put of count comma char for each letter into the max heap, nothing but the priority queue by count. So we are making use of the max heap here, or the max priority queue, right? So just keep this in mind. So we have to always pick the letter with the largest remaining count. Largest remaining count in the sense here, the largest remaining count is C for the first question. So because we have the largest digit, right? So C can appear 7 times. C can appear 7 times. So this is the largest digit we have. So we have to always pick the letter with the largest remaining count, nothing but C first, right? So in this case, after this part, second part, so the third step is if adding it creates three letters, suppose C, 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 we get this one. If adding it creates three same letters, we have to we have to pick the second largest letter from the heap. So see here, CC, if this becomes 3, then we should only go with C. Instead of the third C, we have to consider the second largest. Second largest, this here we have B equals 1. A frequency of A is 1 and frequency of B is 1. We can either consider A or we can either consider B here. So we can either consider A, CCA or CCB here, right? So here in this case, C, that's what they have given here. A we have considered. Here B we have considered would be correct answer as well. That's what they have given here, right? So we will be going with the A now from the heap. So if adding it creates triple C, three same letters, then we have to pick the second largest letter from the heap, add it, and then push back those letters, right? So we will continue until heap is empty or no valid letter can be added. We will continue until heap is empty or no valid letter can be added. So this is what we'll be doing basically. So let's consider the example part. So I hope this is completely clear until here, man. CCA, right? So let's consider the example and let's see. Now first heap consists of the frequency, this one 7C, followed by, this is first one, this is character, 7C, 1 comma a here, 1 comma a, and the third one is this one, 1 comma b, right? So 1 comma in the strings, within the strings b. This is fine. So 7C, because first we will be considering the uh, character with the highest frequency, character that can be present, uh, basically character with the highest frequency, man, sorry. So this is b equals 1, a equals 1. This is fine. So now what we will do, first we will be adding C. So this is having the highest frequency. Accordingly, with the theoretical part or the approach part, we consider first we will be going with a double C, right? So this is fine. Now we will pick A because we cannot pick the third C, right? So no consecutive three letters can appear, right? So now we can either pick A or B. So I'll just pick A, just for the example sake. I'll just pick A here. So now again we can pick C because this can appear seven times, right? So the frequency of the letter C is 7 times. Again we will pick double C, right? So this is fine. Now we can pick B. So this is already finished, so we can pick A only once. So we have already picked the A once here. So now we will pick B. So this can be vice versa as well. We can just pick B first and then A, or we can just go with A first and then B, because frequency of both A and B is 1 here, right? So now we will pick B. Now we will pick B, right? So now what we will do? Now what we will do? We will pick C again. We will pick C again, right? So now we will pick C again. So this is the final point. Then we will pick the two C's again, right? So now we got the word double C A, double C B, double C. This one, double C A, double C B, double C. So overall frequency that we made use of for the C is 6 only, right? So we cannot make use of another C here. So we are done with the frequency of A. We are done with the frequency of B as well. We are left with only C. We are left with only C. If we make use of another C here, if we make use of another C, this will lead to triple C. This will lead to triple C. So no consecutive three letters are allowed accordingly with the question. So we cannot use. So we'll stop here. This will be double C A, double C B, double C. Right? So double C A, double C B, double C. So this is the solution that we got. This is the solution that we got here, right? So let me remove this one entirely. So just give me a second. The solution that we got here is equivalent to the solution that they have given for the example one within the question. So our approach works absolutely correct in this case. See here, so either we can go with this one. You can just consider B here, and then A here. Then A. This also works, right? So this is also fine. This is also fine, right? So the solution that we got is equivalent to the output that they have mentioned within the example one. So our approach works absolutely correct in this case. As we are completely familiar with the approach, let's quickly discuss the complexities part. Right. So now what would be the time complexity here? The time complexity would be pico of A, sorry, just give me a second here. 1 second. So it would be pico of A plus B plus C, this one. So this is fine. uh, and also we'll be going with into log 3, into log 3, because we have the characters, this one, because we cannot have the three consecutive letters. Also we have this one. Uh, Also we have A, B and C, three character count, right? So frequency counts I'm speaking of. So this is fine, I think. Yeah. The overall time complexity would be big of A plus B plus C into log 3, into log 3. Nothing but here priority queue or the heap has at most three elements, right? So priority queue or the heap has at most three elements. So effectively it would be because of a plus b plus c. Effectively, it would be um, because of a plus b plus c. So what would be the space complexity then? Space complexity would be because of 1. Space complexity would be because of 1. Why it is because of 1 here? Why the space complexity is because of 1? Because priority queue or the heap of fixed size less than or equal to 3 we are considering, plus the result string storage. First we have to store the result string. So we have to store the result string, this one, and also we are going with a heap or the priority queue of fixed size less than or equal to 3. Less than or equal to 3, we cannot go more than 3, or right, so we cannot go more than 3, right? So a, b and c we have been given here. So overall space complexity would lead to this one, because of 1 constant size, right? So no extra variables, so only some variables, except no extra variables being added here. So it would be the space complexity would be big of 1. The time complexity and the space complexity for the code that we'll be writing in the future would be big of a plus b plus c into log 3 and big of 1 respectively, right? Big of 1 respectively. So we are done with the this one, what do you call, complexities, complexities and the approach part. So now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Let's start writing the code first as usual. Sorry, first, as we had discussed in the approach, so we will be making use of the priority queue or the maximum, this one, maximum priority queue or the max heap to store the letter and its count, right? So let me go with the priority queue here. This will be, so this has to be capital P, man. Priority queue, uh, int. So this is fine. And pq, let me assign this one to new. This is fine. Again, let me copy this one and let me paste it over here. This is also fine. Within the priority queue, so x comma y, this is fine. This will be y of 0 minus x of 0. This is fine. We are done with the max heap part, or we are done with the max priority queue part. This one now, as I've said earlier, we will be pushing the letters with their counts into the priority queue. If the count is greater than 0, if the count is greater than 0, we are pushing the letters with their counts into the heap or the priority queue. So this is, if a greater than 0, then pq dot offer. So this one will be int new int. This is fine. And so this one will be a comma a comma a. This is fine, a comma a. So let me copy the same thing and let me paste it over here. Let me paste it over here. So this is fine. So this will be b and this will be c, right? So here also this has to be c, this has to be this one c, this one b, and this one has to be b, right? So this is fine. Let's move on with the further steps. Let's move on with the, sorry, just give me a second, 1 second here. Yeah, let's move on with the further steps. We will be making use of the string builder just to store the result string. So I'll just go with string builder sb here, new. Let me copy this one again. Let me paste it over here, string builder. This is fine. So the next step would be, let's write the simple while loop here. We have to get the letter with max count, right? So I'll just go with the while loop here. Let's go with the while loop. So while priority queue is not empty, so I'll just make use of the is empty operation here. So within the while loop, so we have to get the letter with max count. So this one will be int. I'll just go with the first pq dot poll. So this is fine. The next part is, let me go with the length. String builder dot length. This is also fine. So let me go with, let's move on with the further things. We have to check if the two characters are same as current characters. Sorry, we have to check if the last two characters are same as current characters. We have to avoid the three in a row. We have to avoid three in a row accordingly with the condition, this one criteria that they have given on the question, right? So let's write the simple if condition for that. So if length greater than 2, greater than or equal to 2, uh, and string builder dot, I'll just make use of the caret. So this one will be length minus 1. This is equal to first 1. This is fine. And string builder dot caret, this one is fine. This one will be len minus 2. This one equals first of 1. This is fine. So within the if condition, what we will do, no other letter to use. We have no other letter to use, so we will stop. So this one will be priority queue dot is empty. So this is fine. This one will be break. So this one will be break. So this is fine. Now we have to take the next most frequent letter. Means I'll just go with int. So this one will be second. Let me assign this one to pq dot poll. So this is fine. This is also fine, man. So we have to append the second letter. We have to append the second letter, right? So we are making use of the string builder. I'll just go with the sb dot append here. So this one will be char second one. So we are just appending the second letter, and then we have to reduce the count. Nothing but we have considered second here. This will be second of 0. We are decrementing or reducing the count, so minus minus. I hope this is clear. Let's move on with the further things, right? So let's move on with the further things. So now we have to push back if still remaining. We have to push back if still remaining. Let's go with one more if condition. I can just copy and make the necessary changes. Let me type instead. So this will be second of 0. If it is greater than 0, then again I'll just go with pq of pq dot offer operation that is provided by the priority queue. I'll just go with second. I'll just go with a second. So this is fine. So we are just pushing back if still remaining, right? So let's put the first back for future. Let's put the first back for future. Again, as we have to consider the first one, so we'll be going with the offer again within the priority queue, right? So we'll be going with the offer operation again that is provided by the priority queue. So I'll just go with the offer property here. This one pq dot offer. This one will be first. This one will be first. So we are putting first back for future. This is fine. Let me go with else here. Else what we'll do, we will append the current letter, nothing but sp dot append. So this one will be char. So this one will be char. So this one will be first of 1. First of 1. So we have appended the current letter, and we have to reduce the count again. So let me copy. uh, we have to go with the first, right, this time. So yeah, this is fine. First of 0 minus minus instead of second of 0 minus minus. So this is fine. We have appended the current letter, and now we have reduced the count. So this is fine. So again, I have missed something, man, here. This one. So let me make use of one more parenthesis here. So we are appending the current character, right? So this has to be within the current this one parenthesis. So this is fine, man. So we are almost done with the code. Now we are left with only two things. Means here we have to push back if still remaining again. Means if first of 0, if it is greater than 0, then what we need to do, again pq dot offer, because we have to push back still remaining, we have to consider the first one, right? So I'll just go with the first here. This is fine. The final step we are left with here is only one thing, that is we have to return the longest happy string. Nothing but return here string builder dot to string. So this is fine. We are done with the coding part. Let me format the code once, and let me hit the run button. So just give me a second here. Hit the run button. Code is properly formatted, right? So we have the compiler error here. Illegal start of the expression. Where? Line number 16. Illegal start of the expression if length is greater than or equal to 2. Just give me a second here. Length string builder or length we are considering. This is fine. Length equals, so this is fine. If length is greater, oh, this one, yeah, yep, sorry. have left the space man. So yeah, now we are getting the this one accepted, right? So now we are getting the sample test cases are getting accepted, right? So let me hit the submit button quickly. I hope this works for all the test cases man. Let's see. So yeah, you can clearly see here all the test cases are getting passed, means the code works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.